Hey guys, this is Mr. H. I'm doing number 16 from the benchmark packet. Um, this one is your calculator is not going to help you on this one either. You basically have to know the difference between a linear function and an exponential function. And if you're given a table of values, if you put it in a spreadsheet and then you look at the scatter plot, the blue dots, you can usually tell which one is exponential and which one is linear. Okay. But if they give you words, you should also be able to tell when you're dealing with a linear function and an exponential function. Now, remember, linear just means that you're going to be adding the same number every time or subtracting the same number every time. So if you're adding or subtracting the same amount or the same number, then it's linear. If you're multiplying by the same number, or dividing by the same number, it's exponential. Most of the time it's multiplication. But if you are multiplying or dividing by the same number, it's going to be exponential. So that's the difference. So here is kind of how you would do this. So let's look at number 16. It says, which situation can model a linear function? So we need something that basically indicates that we're adding or subtracting the same amount. So the first one says the value of the car decreases by 10%. Now, that's not linear, because in order to get the 10%, we would have to multiply by 10%, right? So it's saying that the car decreases by 10%. So anytime you see a percent symbol, that means you're multiplying, right? Now, the other thing, the second one, it says the number of fish doubles. So if it's doubling every 5 years, that's like you're multiplying by 2. So that is also not a linear function, okay? So if it's doubling, tripling, quadrupling, halving, basically that means it's an exponential function. It's not a linear function. Now, let's look at the third one. It says 2 liters of water evaporates from the pool every day. So that means every day that passes, 2 liters of water evaporates. So every day we're losing 2 minus 2 minus 2 every day. Every day we lose 2 gallons or 2 liters of water. So this is a perfect example of a linear function. And the slope would be 2 over 1. So every day we lose 2 liters. All right, so that would be a linear function. Now, what's wrong with the last one? The last one says the amount of caffeine in a person's body decreases by 1/3. It's got a fraction. In order to do that, you would be multiplying by 1/3. So basically, that's why it's not linear. You're multiplying by 1/3 every 2 hours. So the only one that works is number 3. Now, this one is important enough. I wanted to go over one more. So I went and looked for another question that we could practice on. So this one, we're looking for a situation where that could be used to model linear functions. All right, so, well, hold on. I need to change this to red. So this is a linear function, all right? So now let's go through and find the ones that indicate that we're adding the same number or subtracting the same number. So this one says the value of the car depreciates by 7%. As soon as you see that percent symbol, that means it's not linear, it's exponential. Let's go to the second one. It says a gym charges $50 initially, the initial fee, and then $30 monthly. Now, this is a linear function. And if we wanted to, we could come up with the equation. The 50 would be the y-intercept. So we have to pay 50 to join the gym. And then every month, we have to pay $30. So it'll be 30 times x. So this is definitely the answer. Now let's look at the last two. It says the number of bacteria doubles. Again, that means you're multiplying times 2. So that's not the answer. Cross it off. The last one, it says the amount of money in the bank account increases by 0.01%. Again, as soon as you see this percent symbol, you can cross it off because that means it's exponential. So the answer for this one would be number 2. All right, so if they ask you for linear functions, look for things that sound linear. If they were to ask you for exponential functions, you would be looking for things like percentages or doubles, or that's what you would be looking for. All right. Now, there's going to be one of these on the benchmark starting on Tuesday, so make sure you understand the difference. And if you don't, come see me. All right, I'm going to sign off and post this.